Welcome to this session, students. We were discussing about rational numbers, and we had introduced that a rational number is a number of the form p by q, where p and q are integers and q is not equal to 0. We had seen some of the problems also that you might have understood, and I expect that you can try some more problems based on that, so that will deepen your understanding about the concept of rational numbers. Now, this is the biggest set of rational numbers till now, whatever you have studied. The rational number system, the rational number collection of rational numbers is the biggest of all till now, whatever numbers collection of numbers you have studied. For example, natural numbers, integers, whole numbers and so on. And all of these are a part of rational numbers that we have seen in our earlier sessions. Now, proceeding further, because they are numbers, so they might be having some properties, they might be behaving in a particular way. We would like to see here also the different types of behaviors of this particular collection of rational numbers under different operations: addition, subtraction, multiplication and division. You have seen in earlier classes about the addition of integers, subtraction of integers, multiplication of integers and division of integers. What kind of properties do they satisfy, how they behave when you divide two integers, or when you add two whole numbers, or when you subtract two natural numbers. What exactly is happening there, and that we establish it as a property, and these properties we want to see whether they hold for rational numbers or not, and in comparison to these, how these rational numbers are behaving. I mean, when I talk about the closure property, that we discussed about closure property, that we are combining two numbers of the same collection of numbers, then we would like to see whether the resulting number that you are getting is out of that collection or it is a part of that collection. For example, when I talk about whole numbers, when I say 2 plus 3, that is equal to 2 and 3 both are whole numbers, and when I add them, whatever number I get, it should also be a whole number, and our mathematical facts suggest that that is equal to 5 and that is also a whole number. You check it for different, you have already done it for different whole numbers, and so in general we say that a plus b, if a and b are whole numbers, then a and b, a plus b is also a whole number. But does this hold for all the operations that we do? Whatever combination of numbers we take under different operations, here I have taken addition as the operation, will it also hold for subtraction? It will not hold for subtraction. It may hold for some pairs, it will not hold for other pairs, and when it happens that it does not hold even for one pair, we will say that it does not hold for that particular number system. For example, when I say 2 minus 3, 3 minus 2 is equal to 1, that becomes a whole number. But when I take 2 minus 3, will it be a whole number? It will not be a whole number, it will be an integer, in fact negative integer. This is not a whole number. So, it is not closed under the operation of subtraction. The set of the collection of whole numbers is not closed under the operation of subtraction. Will it be closed under the operation of division? Let us see that. If I take the same two whole numbers, for example, if I take the numbers as 4 by 2, I have taken two whole numbers 4 and 2, and I am dividing 4 by 2. What do I get here? I get the number 2. What is this 2? 2 is again a whole number, but can we say that whole numbers are closed under division, operation of division? Let us check this. Just invert it and see what you get here. 2 divided by 4. 2 divided by 4 is 1 by 2. Is this 1 by 2 a whole number? This 1 by 2 is not a whole number. So, we will say that in general division is not commutative for whole numbers. So, in this way we try to verify the different properties, and sometimes it holds for that particular collection, so many times it does not hold for that collection. Now, these things you have studied in earlier classes, and now we have introduced the concept of rational numbers in comparison to all these systems that you have studied, the collection of numbers that you have studied. How does this rational number behave, that we want to see. For example, when I talk about the closure property, you can say that if you add two rational numbers, say minus 1 by 2 and say 5 by 2, you will see that the resulting rational number is nothing but 4 by 2, which is equal to 2. Even if I do not simplify it, this itself is a rational number. So, ultimately under this particular operation of addition, it is satisfying this. You can check for many more such pairs of numbers, and you take all those pairs where negative rational numbers are there, positive rational numbers are there, try to combine them using the operation of addition and see what you get as the resulting number. You will find that you always get a rational number. Similarly, under subtraction, if I try to subtract this, say 3 by 4 minus say 7 by 4, and I get here, as per the operation of subtraction of rational numbers, I get here minus 4 by 4, which is equal to 1, minus 1, which is equal to minus 1. What is minus 1? Minus 1 is again a rational number. Now, it means that you can check it for different such pairs of numbers. I have just given one example, I have just quoted one example. You take different pairs of such rational numbers and try to do it for yourself, try to share it with your students and teachers and tell your observations to them. Now, here you can see that under the operation of subtraction, the collection of rational numbers is closed, because whatever resulting number you are getting, it is again a rational number. Will it hold in the case of natural numbers? Just now I showed you that for if I take two whole numbers, for example 2 minus 3, or if I take two whole numbers 0 and 2, will 0 minus 2 be a whole number? It will not be a whole number. Will 2 minus 3 be a whole number? It will not be a whole number. So, it is not closed under the operation of subtraction, the collection of whole numbers and the collections of natural numbers, but the collection of integers is definitely closed under subtraction. For example, I can say minus 5 minus 7 is equal to minus 12, which is again an integer, or I can say 5 minus 7 is equal to minus 2, which is again an integer. So, it is closed under the operation of subtraction. So, look, as soon as the number system is extended further, you can see the change in property of the numbers that have been introduced there. So, in the case of integers, subtraction is closed. In the case of rational numbers, subtraction is closed, but this does not happen in the case of natural numbers and in the case of whole numbers. Now, when we talk of rational numbers and integers, this we have done. What about the property under the operation of multiplication? If you multiply two whole numbers, you are going to get a whole number again. For example, when you multiply 4 and 5, you get 20, which is again a whole number. These are natural numbers as well. Even if I say 0 multiplied by 6, 0 multiplied by 6 is again 0, as you know that, and we are getting whole numbers again. If you treat them as natural numbers, you are again getting a natural number there. This is a whole number here, you are again getting a whole number here. So, the collection of natural numbers and whole numbers, they are closed under the operation of multiplication. Similarly, the integers also, if I multiply these two integers, minus 2 multiplied by say plus 3, I get here minus 6, or minus 2 multiplied by minus 3, I get plus 6, again getting integers here. So, I can say that under the operation of multiplication, the collection of integers is closed. The collection of integers is closed. Will it also happen for the rational numbers? You take any two rational numbers here, say minus 2 by 3 multiplied by 5 by 7. What do you get here? Minus 10 upon 21. This is again a rational number. Minus 2 by 3 is a rational number, 5 by 7 is a rational number, and the product you get here, that is minus 10 by 21, is again a rational number. You can take many such pairs and try to verify for yourself. We can say that rational numbers is closed under the operation of multiplication. So, as far as addition and multiplication are concerned, they hold for the number systems are closed under these operations, whether they are, it is natural number system, whole number system, or the collection of integers or the collection of rational numbers. They are all closed under these two operations, addition and multiplication, but it varies for subtraction. For subtraction, whole numbers and natural numbers, they are not closed, we have seen, because we can get pairs of numbers whose subtraction is not a part of that particular collection. But in the case of integers, yes, it holds, that is, the integers are closed under the operation of subtraction, and rational numbers, collection of rational numbers are also closed under the operation of subtraction. As far as division is concerned, natural numbers, whole numbers and integers, they are not closed. For example, when I talk about integers, if I say minus 2, if I say 4 divided by minus 2, I can get here minus 2. This is no doubt an integer, but if I take minus 2 divided by 6, this will no longer remain an integer, this becomes a rational number here. So, whatever resulting number you are getting, it is not a part of collection of integers. Minus 2 is an integer, 6 is an integer, but minus 2 by 6 is not an integer. So, division is not closed. Under the operation of division, the integers are not closed, we will say, because you are getting a number which is thrown out of the box. So, it is not at all closed. But if I take two rational numbers, for example, if I take the numbers as 2 by 3 divided by minus 1 by 7, if I want to divide these two, I can say that this is nothing but 2 by 3 multiplied by minus 7 by 1, and that is minus 14 by 3. So, we can see that apparently it appears that this particular thing is closed under division. 2 by 3 is a rational number, minus 1 by 7 is a rational number, whatever division we got, whatever quotient we got, it is minus 14 by 3 is again a rational number. But friends, mark one thing, that rational numbers also contain this particular number, that is 0. So, when you say 0 divided by minus 2 by 7, you are going to get 0. 0 divided by minus 2 by 7, you are going to get 0, which is again a rational number, but try to do it the other way around. Minus 2 by 7 divided by 0 will not be defined. Any number divided by 0 is not defined. So, the collection of rational numbers in general, that particular collection of rational numbers is not closed under division because of this one element, because of this particular number 0. You remove this 0 from the collection of rational numbers, you do not take it for a moment in the collection of rational numbers, that is, you take the collection of non-zero rational numbers, you take the collection of non-zero rational numbers, and you will find that this property of division is also under this particular property, the numbers are closed, the particular collection is closed excepting this particular number. So, if you keep this number aside and take the remaining numbers from that particular collection, for them this particular operation will be giving closure property, will be satisfying the closure property. You can see here, as we are proceeding, as the number systems are extending, there is a little change in the properties as well. Initially subtraction was under subtraction, the number systems were collection of numbers were not closed, but as soon as we extended it to integers, they became closed. We extended it to rational numbers, they were still closed, but the operation of division also, till integers they were not closed, but the moment I take non-zero rational numbers, it becomes closed. So, this particular thing is interesting to see and try to compare the different properties of the number systems, that the number of collections, the collection of numbers that you find or that you have studied till now, and you will find interesting things in this particular thing. Now, let us switch over to another property, that is commutativity. What is commutative property? You have seen this, that if I take the operation of addition, it means that first you must have a collection of numbers, then you must have some operation and operate the numbers under this particular operation and see what are the properties there. Either the number will be a part of the system or it will not be a part of the system, that becomes a closure property. Similarly, for other operations and number systems as well. Now, here I am talking about commutative property. Commutativity, that we call the property of being commutative is commutativity. So, commutative property, what does it say? If you exchange under a particular operation, if you replace one number by the other, for example, if you interchange the numbers, the value of that particular expression will not change. For example, if you say 2 plus 3, look at the arrangement of numbers here, this is 2 first, then 3, and you are adding these two, you are getting here 5. Change the arrangement of numbers, and see what you get. 3 plus 2, again you are going to get 5 here. We say that under the operation of addition, whole numbers are commutative, or they commute with each other, the whole numbers commute with each other. Similarly for natural numbers, because whole number is a bigger part of natural numbers. Similarly for integers, for example, if you say minus 2 plus 3 is equal to, as you know from the operations of integers, addition operation, this is nothing but 1, and if you say 3 plus minus 2, again you are going to get 1. It means that just as here 2 plus 3 is equal to 3 plus 2, here also minus 2 plus 3 is equal to 3 plus minus 2. The numbers have commuted, they have been interchanged, and still their value remains the same. And so we say that the collection of integers, the collection of whole numbers, the collection of natural numbers, they all satisfy the commutative property, they are all commutative under the operation of addition. Will it hold for the other operations? For example, if I take the operation of subtraction, so can I say that 2 minus 3 is the same as 3 minus 2? Here you will find that the value is minus 1, whereas here the value is 1. So, they are not equal. It means that if I interchange the numbers across this particular operation, it is not going to give you the same values. For example, if I take here integers minus 2 minus of minus 3, what do you get here? Minus 2 plus 3, and that is nothing but 1. But if I take here minus 3 minus of minus 2, what do you get here? Minus 3 plus 2, and here this is nothing but minus 1. Under the operation of subtraction, we found that the natural numbers, the whole numbers and the integers, they do not commute, that is the commutative property does not hold, and for the operation of subtraction on the collection of numbers, that is natural numbers, whole numbers and the integers. So, here you can see that one more thing you need to observe, that these were not also closed. When I talk of natural numbers and whole numbers, they were not closed, under the operation of subtraction. Natural numbers and whole numbers were not closed. They were not closed, so they are not commutative as well. They are not closed, they are commutative as well. But the collection of integers is definitely closed under subtraction. The collection of integers, that is minus 3 minus of minus 2, how much you are getting here? Minus 1, it is an integer. Minus 2 minus of minus 3, you are getting 1 here, it is again an integer, it is closed under that operation, but still the commutative property does not hold there. Similarly, you can see for the collection of rational numbers. What happens for the collection of rational numbers? I will take the simplest one, 1 by 2 minus 1 if I take, what do you get here? Minus 1 by 2. But you do the other way around, 1 minus 1 by 2, you are going to get here 1 by 2 simply. So, as far as the addition and multiplication operations are concerned, all these number systems, all these collection of numbers are going to satisfy the commutative property. You multiply any two whole numbers in any order, you multiply any two integers in any order, you multiply any two natural numbers in any order, and you can multiply the any two rational numbers in any order, you are going to get the same thing. So, commutative property holds for these two operations, addition and multiplication, but for subtraction it does not hold for natural numbers, whole numbers and integers. Will it hold for rational numbers as well? No, it does not hold for rational numbers, because at one place you are getting minus 1 by 2, at the other place you are getting plus 1 by 2. So, these two are not equal. We will say that rational numbers do not commute under subtraction, under the operation of subtraction, the commutative property does not hold. Look at the properties again. In the case of closure, natural numbers, I will denote it by just letter n for to be brief. Natural numbers were not closed under subtraction. Natural numbers were not closed under subtraction, whereas under the same operation they were not commutative as well. Under the same operation they were not commutative as well. I just want to give you a brief picture of what we have done till now. Similarly, for whole numbers, they were not closed under the operation of subtraction, they were not commutative as well under the operation of subtraction. What about integers? Integers were closed under the operation of subtraction and they are not closed under the operation of subtraction. What about rational numbers? Rational numbers are definitely closed under the operation of subtraction, but they are again not closed under the operation of subtraction. Look at this. If this is not closed, then definitely they are not going to be commutative. But if they are not closed, it can happen that they are commutative. It may or may not be, that is the situation, but if it is not closed, then the case ends there. It will not be commutative and we will see the further properties as well, whether those further properties also hold or not. So, that is more important, and this comparison of properties is more important, not merely playing with numbers. You need to play with numbers, no doubt, to get an idea of what kind of properties or how they are behaving, but ultimately you need to generalize it and finally express it in terms of letters. You have learnt algebra, you know what are variables, you know what are constants. So, in terms of these symbols, you should be able to express them and write a generalized form of your observations. That is more important. So, when I say A and B are two whole numbers, A and B are two whole numbers, then A minus B need not be, mind my words here, need not be a whole number. Similarly, A minus B, A and B are natural numbers, A minus B need not be a natural number, and so on. A minus B can be an integer if A and B are integers. A minus B can be a rational number if A and B are rational numbers. So, try to play with these ideas, try to project your ideas in this way, try to convey them to your friends, to your teachers and someone else who may not be from your school, but who would be interested to listen to you and your observations. So, that is more important here. Similarly, here I was talking about the connection of one property with the other property. If a certain collection of numbers is not closed, then it is definitely not going to be commutative. If it is closed, it may or may not be commutative. So, that is the relation that till now whatever we have seen, but for that you need to have large collection of such examples with you. Try to generate these examples, try to give it to others and try to find it out for yourself. So, students, we have seen the properties of rational numbers, that is closure and commutativity under all the four operations. Try to compare it with the earlier learnt collection of numbers, and this comparative study of the properties of numbers, of different number systems, rather collection of numbers we call number systems, will help you to get an idea of how the extension of number system helps you to generalize things and to see the things in different way. There are some more properties that we are going to study in our, or we are going to discuss in our next session. For the day, we will close here. Thank you so much.